Right. So, welcome. Today we are talking about application and platform modernization. I'm John, those of you who don't know me, from the Scale Factory. We're a consulting partner with AWS, working predominantly with SaaS businesses. We recently were awarded the SaaS SI Partner of the Year award for global partners at reInvent last year, which we're very proud of. Just as we get going, we're going to start with a poll, get to know you and your sort of interest in today's stuff. So moving on. So basically, what I'm here to tell you today is that regardless of what you've built and when, your architecture is out of date, right? It is universal truth that as soon as you build something in the world of technology, something newer is already available by the time you've completed that project or not long afterwards, because technology moves pretty quickly. And as an example of this. This is a screen capture from the AWS What's New page, and the AWS What's New page selected to filter by things that are new in 2024. So in just 2 months, there are 275 new things going on in AWS. Not all sort of big new feature releases and those sorts of things, but plenty of small changes and little bits and pieces here and there that advance the platform and give you things to worry about using. It's also the case that depending on what you've built your application in, probably the libraries you're using, the frameworks, etc., are probably also moving quickly and out of date since you adopted them. So there's a constant of change. Everything's changing all the time. Those of you who've done a lift and shift migration to get applications to the cloud, typically this is taking something that was on premise, maybe on physical hardware or on VMs, type of migration we're probably going to see a bit more frequently now that VMware have massively increased the pricing of vSphere, and typically a lift and shift migration doesn't really adopt the features that make up the full breadth of the cloud technology platform. So you typically pick up a VM, move it into the cloud, sit it on an EC2 instance, and call it a day. And so if you've done this type of migration, there is almost certainly opportunity for modernization in your workloads today. If you built cloud native, but you did that maybe 2 or more years ago, then probably plenty of opportunity to modernize here as well. As we said, the cloud is moving pretty quickly. There's lots of change all the time, and so there will be things that are out of date in your platform today where you could benefit from improving. Benefits by improving your platform by adopting some of these new changes. So the things that you might see in your business, if you are in a position where you could modernize, you might see a lack of agility. You might be unable as a business to react quickly to the changing landscape and demands of the market. You might find that there's a lack of flexibility, so it's difficult to make changes to the applications that you have deployed. You might find that you're lacking in scalability, so you can't introduce new application features, or it's difficult to extend existing features that might involve new users or capacity. You might have issues with performance in your existing platform, so maybe missing SLAs in terms of performance, page speed, or API response time, that sort of thing. You might also not have good data insights if you're working on a platform today where you cannot surface data about how it's working, about how your customers are using it. Then there are probably opportunities to improve there. That's probably slowing you down. You might have, if you're running on an older platform, some degree of security risk. Applications with vulnerabilities as a result of them being a little old. Whereas a more modern way of thinking about building infrastructure is to build security in and integrate it throughout the application. If you're finding it expensive to build new applications, it costs a lot of developer time or actual real money to build new things, then that might indicate that you've got scope for modernization as well. And in general, if you have high costs, higher infrastructural costs, there might be opportunity to modernize and reduce those costs as well. So my assertion is that failure to modernize is essentially technical debt. As the platform and the components that are available to you evolve over time, if you are choosing not to follow that path of evolution, you are essentially taking on technical debt. You're deciding instead to do other things, which is fine. Often that is the right call. We can't be refreshing our architecture every year, but over time, technical debt sort of builds up, and technical debt is really the source of the types of problems that we talked about before. So lack of agility, lack of flexibility, cost. These are all concerns that you'll hear from people if there is just general technical debt in an infrastructure as well. I'm going to share a type of diagram here that you might have seen before. This is a Wardley map, courtesy of Simon Wardley, who you may have seen speak at KubeCon or at various government-related events. I think he was quite big in GDS at one point. On a Wardley map, we have two axes. On the vertical axes, we've got how visible is a component to the end user. And on the horizontal axis, you've got the evolution of that product, and the assertion that Simon makes here is that over time, things that are novel eventually become commodity. They evolve to become something that you can just buy off the shelf. I'm going to share an example here of. This is the Scale Factory is 15 years old this year, and 15 years ago, I built a platform for a company called Songkick, who were doing gig ticketing and discovery, and we built a MySQL cluster for them. And in the days of 2009 database hardware, this was in a data center, and we had to build all of the components around config management. We had to build high availability into the solution. We had to add monitoring ourselves. The MySQL daemon itself depended on compute and storage that had to go in a data center. Data center provided power and networking as commodities. And you can see that on the way that it's presented on this graph, MySQL itself is presented as a product. The compute and storage were products. These were Sun or Dell servers with disks in them. The data center was essentially a product, but the data center is providing power and networking, which are commodities at that point because they could have bought power and network from basically anywhere. And over time, these things evolve, and today the MySQL landscape looks a little more like this, which is that you can just use a piece of software from a cloud vendor, which they will sell you as a commodity. And so in the 15 years since we built Songkick, it is now possible to get actually a much better MySQL solution, but more scalable, more highly available, more performant, without having to do all of that legwork that we used to do instead. You're literally making an API call, and 20 minutes later you've got a running database. Whereas in the old days it would be weeks of building servers and plugging things together and setting up config and testing and so forth. And this is what progress looks like, and I'm generally in favor of it. If you look at the sort of timeline of AWS as a platform, there've been a number of notable things launched over the years that if you haven't adopted those as you've gone, you've maybe missed an opportunity to make use of a commoditized version of the thing that you've built yourself. So as an example here, 2021 Amazon OpenSearch, that's an Elasticsearch compatible service. In the old days, 5 to 10 years ago, we would have been building Elasticsearch clusters on EC2 instances and building the config management tooling to do that and having to back them up ourselves. And today you can use these services off the shelf from AWS as a service. So what are the strategic reasons you might want to think about modernization other than the ones we've talked about? Well, you might think about modernizing your platform in order to support changes to your people and your processes and your business. You might want to reorganize your organization into small product teams that all work on a full stack, rather than having maybe a DevOps team over here and an engineering team over here and a QA team over here. You might take individuals from each of those and say you are now working on this product. And doing that without also supporting that sort of change in the architecture is probably going to cause you trouble. You might want to decouple services from each other. So often companies will start by building a larger sort of monolithic application, and over time you get to the point where you've got large numbers of developers working on this thing, and those developers can't all easily collaborate on that monolith, and it slows things down. And so it sometimes makes sense to take parts of that solution, split it up into separate services or microservices in some cases, and allocate those to teams to work on. And so you need to be able to support that in the architecture. That's an architectural change that's driving some kind of organizational change. You might want to get better business insights, right? We talked about data earlier. If you're not surfacing data from your platform, then it's going to be difficult for you to make business decisions based on what your users are doing or what's going on the platform. And so building a modern platform that provides better access to data might be the goal. Might be the case that you want to iterate more quickly on new ideas, take a product from nothing to the market in a shorter amount of time. And so creating a platform that is friendly to builders to allow that is maybe your goal. Or it might just be that your developers are spending too long maintaining things like Jenkins servers or Elasticsearch servers or other pieces of technology that are sort of from maybe 5 or more years ago, where with a bit of time investment, you could move that function into a managed service and free up time to work on actual business problems. So those are the strategic reasons you might want to think about. The business results that you might get from that are you get to move faster and iterate on new products, and what CEO doesn't want to do that? You might save some money on your IT spend, reducing the cost of running these services. And you might get better outcomes for your customers in terms of SLAs around performance or availability and so forth. So let's talk about how to modernize. Like what is the actual approach here, which is maybe why some of you have dialed in. There are two things to think about, I think. You've got modernization of your AWS estate as a whole and individual workloads within that estate, and we'll look at each of those separately because they are separate considerations. In the sort of beginning days of AWS, what you typically do is create a single AWS account, stuff everything into it, and you might eventually sort of bump up against limits there. But it's not unusual for us to see workloads over a certain age that are all in one account, which has problems from a security and blast radius change blast radius perspective. But that today there are better ways of doing that. You might have started in a single account and then maybe split out accounts by environment or something like that. But you can go much further than that. And today the best practice is to go further. The well-architected guidance is to provide a self-service multi-account AWS environment that covers account and networking structure, identity and access services, security baseline guardrails, cost guardrails, centralized management, logging and monitoring, and account application blueprints. We call this a landing zone. A landing zone is sort of a mechanism for providing accounts that have been baselined well with all of these considerations as they're provisioned. We use there's an AWS service called Control Tower for this. And if you've used AWS for more than a couple of years, it's fairly likely that you haven't adopted Control Tower, and it is a really good idea. It's sort of the tooling that was missing when AWS was first created for managing accounts properly. And who doesn't want to manage their accounts properly? It's good to think about putting a landing zone in before you start thinking about modernizing applications, because the governance it provides helps you do a better job of application modernization. Ultimately, good architecture leads to good governance, and governance is it's a sort of boringly named topic, but it's an important thing in certainly in growing businesses where you might have a number of teams all working in the cloud, and you want to be certain that they're all doing it well. And the concerns that you probably have from a governance perspective is, first of all, security. Who can access the resources? Is it locked down sufficiently? Are your encryption policies enforced? Whereabouts are we storing information that is confidential and so forth? And these are the types of things that a CISO in an organization really cares about. And the CTO in a maybe in a less advanced organization where there isn't a separate CISO is probably thinking about these things as well, maybe keeping him up at night. Cost, you've all mentioned cost as an issue. Cost governance is really about whether you're paying too much for the things that you're using, whether you're generating waste, standing up resources that you're then not actively using. Is there a way in which we can avoid generating a large bill? There are certainly a lot of nasty surprises to be had with certain architectural decisions from a billing perspective. You want to, in a larger organization, an enterprise kind of sized entity, you want to be able to break down parts of your cloud bill by department and understand how spend is attributable to business units or product lines. And if in the SaaS world, you want to understand which of your tenants are costing you how much money so that you can tell whether or not the tenant that is generating the most spend is also the tenant that's bringing you the most revenue, making sure that costs are equivalent to revenue in the SaaS world, in terms of size at least. From a CEO perspective or a CTO perspective, how can we manage all of these things? Like I've just talked about a lot of stuff. How can we manage all that complexity without slowing down too much? And how can we ensure that product teams or service teams can work on their products or services in a fairly autonomous way and choose their own language environments, their own testing strategies, that sort of thing, but whilst also conforming to local policy as far as security, cost, and so forth is concerned? And an AWS control tower deployment looks a bit like this. I'm not going to go into it in any detail. We've deployed about 60 of these over the last few years, so we're pretty good at it by now. If you'd like to know more about control tower and account management and governance, you can drop me a line afterwards and we can talk in more detail about that. So let's talk about individual workloads now. I think if you're deciding that you want to modernize your platform, it probably makes sense for you to identify some kind of priority. Like, why are we doing this? What's the motivator for doing this? And these are the 6 well-architected pillars. It's typical that if you're doing a modernization project, you're doing so in order to target one of these pillars to some extent. And so figuring out why you are modernizing and choosing the pillar allows you to also then decide how you're going to measure whether what your modernization project is actually working. So from a security perspective, you might, for example, engage a partner to do a well-architected review and highlight the number of high-risk items that exist. In theory, after a modernization activity, you should have fewer high-risk security items. From an operations perspective, you might be familiar with the DORA metrics and the DevOps Research Organization. These are about frequency of change and ability to recover from failure and that sort of thing. So you might choose to measure DORA metrics, how many deployments are we managing in a day, that sort of thing. From a performance perspective, you might want to measure application performance. Reliability might be about your uptime or how long it takes you to engage your disaster recovery plans. In terms of cost, you might measure how visible cost is. Certainly an issue with cost pre-modernization can be that you don't really know where that spend's going or why. You just see the one number and it's not really clear where that's going. But also measuring the total cost and hoping that it's lower as part of your modernization strategy is a good bet as well. And from a sustainability perspective, the sustainability is kind of linked to cost in many ways, but you'd like to see a smaller footprint of compute in order to hit a sustainability goal as you modernize. So you choose one of those approaches. Now that you know why you're doing your modernization project and you are what you're measuring to determine whether it was successful, you want to choose one workload to work on. It doesn't make any sense to modernize your entire infrastructure in one go. So you might choose, for example, if there's a new project of some kind that's going on, you might choose to use that project as a way to demonstrate a new way of working. Some of our clients, when we're working on projects with them, they brought us in to show them a new way of working. And so the work that we're doing is designed as an exemplar for everything else that's going on in the organization and to guide future modernization projects. Or you might choose an existing workload. If you do that, it sort of makes sense to choose one that has high impact. Because if you're a larger organization and you've got a number of AWS workloads that are running today, then what you want to be able to do is demonstrate that you can modernize an important workload so it justifies continuing to do that with the rest of your estate. So choosing a high impact workload is a sensible play. Maybe not necessarily a complex workload. Maybe you can find something that is relatively simple but also high impact, and start there. But impact is really the important thing there. And then as you're thinking about how to re-architect parts of your platform, my advice really is to adopt managed services where you can. These are typically going to reduce your operational overhead. You need to spend less time managing a managed service because your vendor is already managing it for you. Typically, it's the security posture of a managed service is better. Again, because somebody else is managing the patching and the security posture for you. They're typically pretty cost effective. It takes away a lot of the sort of manpower cost of running a service, even if sort of like for like, it looks a bit more expensive to run, say, a containerized workload on Fargate than it is on EC2. With the EC2 story, you're also managing the operating system and patching it and sort of sorting out deployments and that sort of thing. Whereas the Fargate solution takes care of all of that for you. AWS services also have a higher pace of innovation. It doesn't matter how many developers you've got in your business, you have far fewer than AWS have. And AWS are investing constantly in improving their offerings. I wrote a blog post about this, the reInvent before last. AWS changed the read after write semantics of S3, which is kind of a big deal, a huge set of changes across 200 or 250 microservices for them. But now you get to benefit from that. You haven't had to make any change at all to your application. It just works now. Actually works in the way that you probably thought S3 worked in the first place. These services are also exceptionally reliable. AWS certainly does have outages from time to time, and there are faults, but compared to running your own stuff, fewer and much further between, and typically not across all of their customers in one go. They're very good at just a limiting blast radius of change. They're particularly good at that side of operations. And the AWS services are highly scalable. If you're adopting something like DynamoDB or S3 or Aurora, these things go massive before you bump into scalability issues in a way that building something yourself, you probably won't quite get it there. So we'll go through some types of service and look at the types of decisions you might make from an architectural perspective. In the compute landscape, before modernization, particularly if you've done a lift and shift migration, you might be looking at a workload that is built on EC2 instances or running on VMware Cloud on AWS. These are workloads where you are having to run the operating system inside either a physical machine or a virtual machine, and you have responsibility all the way down to the metal for that, including patching and making sure that your network drivers are performant, all those sorts of things. After modernization, what you might choose to do is to adopt something like AWS Lambda, a fully serverless solution where you are firing bits of code into AWS and having it run on your behalf, which is the sort of the most serverless approach you can go for. Or you might think about adopting AWS Fargate, which is a containerization solution. It's a serverless container orchestrator, so you are, again, not worrying about the operating system and so forth. You're scheduling containers, and AWS is running that for you. And if you've got a particularly complicated workload or a team structure that requires you to have built a platform, then something like Kubernetes running on EKS might be a good choice. Again, containers. And in all of those cases, you're pretty much giving the responsibility for running the operating system and an awful lot of the security and scalability concerns to AWS to run on your behalf, and that makes your life easier and reduces the cost of your manpower, if not the services themselves. But if you're adopting AWS Lambda, actually you're only paying for the compute resources that you're using, and for certain workloads, you can save a huge amount of money and really meet your sustainability goals with Lambda, because you are literally only paying or using compute when there are requests being made. In the data landscape, a lift and shift migration might have led you to be running a database on EC2 instances. We don't see that a lot these days, but it's something that we have seen in the past, particularly where you might be using a database solution that requires like custom plugins and weird things like that, all of which are now much easier to support on Amazon's offerings. You might also be using Amazon RDS, which is their managed database solution, which is a perfectly reasonable choice. But after modernization, you might adopt Aurora, which is a much more serverless, hands-off way of running the same type of database. Greater performance in some cases, certainly cost equivalent, if not cheaper. You might adopt instead DynamoDB, which would require you to change some of your software to use a different type of database, but that might give you scalability improvements or cost reduction because of the way that Dynamo is priced. If you're thinking about file systems, running a pre-modernized application on certainly on a lift and shifted type of infrastructure, you might be just storing files local to the EC2 instance in an Elastic Block Store, or you might be shipping files over an NFS connection into EFS, both of which perfectly fine, but have scalability limitations. You might, after modernizing, consider that you should store your files as objects in S3 instead, and maybe adapt your application to make API calls against S3 instead of looking locally for files. And those are reasonably easy changes to make in an application typically. Certainly not huge and complex. Or if you do still need kind of file system level access to some of these things, or you need extremely high performance, you can do things with services like FSX for Lustre. We're currently working with a company in Switzerland who are doing medical imaging, and they do huge HPC jobs on the data that comes out of the X-ray machines that they're building that gets shipped into S3, and then a parallel HPC job spins up and uses FSX for Lustre to get at those files through a file system interface at really high performance, and to churn through that data really well. So plenty of file system options in the AWS landscape for sure. In the CI/CD world, many of you might have worked with Jenkins running on EC2. Certainly, that was the bane of our lives for a number of years. Today, there are better options for sure. There's a suite of tools from AWS for running CI jobs and deploying software. Some of those have security scanning plugins. Actually, we worked with Sneak, a security vendor, on embedding their scanner into Code Pipeline or Code Commit. I can't remember which of the tools it was. There's also GitHub Actions, which is quite popular. We tend to in our solutions we're using GitHub Actions quite a lot these days, and certainly we're not spending a huge amount of time with Jenkins anymore, which certainly makes me happy, if not anybody else. So having looked at your design and figured out how you're going to replace components within it with things that are maybe a little more modern, and you've done this for an example workload, the trick is to make sure that you're taking the learnings from that process and creating blueprints so that you can do the same thing for other workloads relatively easily. And that might be by using some kinds of design patterns. It's probably going to involve building reusable infrastructure as code automation, whether that's in Terraform or in CloudFormation or something similar. And if you are building out onto Control Tower, as we talked about earlier, you can take those blueprints and turn them into service catalog entries so that if you've got, for example, a design pattern around building and deploying containers on AWS, you can turn that into a service catalog entry that then other business units in your organization or other teams can just use as they create new accounts. They can say, I want to run containers in this, and it'll get all of those, Fargate workload and maybe a code pipeline to get code out onto there. So thinking about reusability is the important thing here. So wrapping up, just to recap, I guess the advice here. Main takeaways: worth getting your estate in good order with an AWS landing zone using Control Tower in order to add a good level of governance around how you are doing things on AWS across the board. There are easy ways to get going with that, and we can certainly help you deploy one of those if that's something you'd like to do. We actually have fixed price offerings around that because we've done it so frequently. We also recommend that you choose an impactful new or existing workload to modernize. Keyword is impactful. It's important to choose workload to modernize that you can use really to show success so that you can get buy-in to continue doing that for the rest of your estate. And as you're modernizing, adopting managed services is really the best way to go about this so that you can reduce the number of things that you have to run yourself, improve the security posture, and probably reduce cost as well. And then use what you learn through having done that work in other workloads. So create blueprints, create reusable components, and share those across the organization. How can the Scale Factory help? Well, co-investment with AWS funding is an option. We have access to funding programs from AWS that help pay for some of this type of work. And if this is something that you are looking at in your organization, do drop us a line and we can help you figure out what funding is available. There can be significant figures attached to these types of projects. AWS are very keen to help you get modernized by throwing money or credits at you. So do get in touch if that's of interest. We can also, we do offer free consultancy around these types of projects, just to sort of kick the tires on where you think you are, where you'd like to get to. We might suggest a deeper dive review. There are typically ways that we can cover the costs of that as well. I can see a question from Antoine. How do you measure the gain of doing that? Yes, you did in fact miss the bit of the presentation where I was talking about that. Let me find the slides so that we can recap. Essentially, the recommendation is that you choose. Where is? There we go. Figure out what is your priority for modernization, right? Which of these things do you care about the most? Is it security? Is it cost? Those are typically the two sort of big ones. And then there are mechanisms that you can use in each of those pillars to figure out how you're performing today. Is it the number of security risks you're carrying? Is it the rate with which you can deploy software? And measure that in your modernized world and measure it in your post-modernized world, and you should see the improvement there. If there are other questions, I will happily take some other questions. Otherwise, we'll wrap up. Either stick them in the chat, or if you feel like it, turn your mic on and ask in actual voice mode. All right. Well, thanks very much. I'll be sharing a video of this on our YouTube channel if you'd like to catch up. And if you'd like to get in touch beyond that, you can find us at scalefactory.com, and there are contact details on there. Thanks very much for your time. We'll speak again soon.